So welcome to our Sec 3 E-Math revision event. Today we are going to be covering on quadratic equations, sector area, and your similarity and congruency. Okay, but take note, for congruency and similarity, we are only talking about 2D and 3D diagrams. So area and volume. Okay, so my name is Mr. Clarence, and the subjects that I teach at OVERMUGGED are lower secondary math and upper secondary E-Math and A-Math. And I have 4 to 5 years of teaching experience, which I try my best to help students excel in their mathematics exams. Okay, so over the course of these 4 years, I have guided about 70% of my students to achieve distinction for their major exams, be it end of year or O-level examinations. Okay, so one fun fact about me, I'm not sure if this game is still relevant, but I was once Singapore's number 17 carry in Mobile Legends. Okay, I don't think anybody plays this game now, but this was a few months ago. Okay. So briefly to talk about our center, we have 7 branches across Singapore. So this is one of the 7. So if you, for example, if you don't stay nearby, next time you can consider other locations. Okay, so you don't have to make the trip down. Okay, then afterwards, talk about resources. We provide curated notes, which is our form of textbook that we create on ourselves. And we have WA revisions as well. So WA1, WA2, and WA3, we should have revision events. Mock exams for our O-level students, and we also have science practical notes and science experiments for those who are interested in science. Okay. Okay, so with that, we will start with the lesson today, and today's class size is slightly small, so you don't need to be too worried about asking questions or answering questions in class, right? Because there's nobody around here. And even if you get it wrong, it's fine. Nobody's gonna laugh at you. Nobody's gonna care whether you got it wrong, right? You're here to learn. Okay, if you know everything, you won't be here already. Okay, so if you got any questions, please ask. And if I were to ask you all to answer my questions, I hope you can give me an answer as well. Okay. So over here, we look at the first portion, which is your quadratic graphs. Okay. So your quadratic equation is in the form of y equals to ax squared plus bx plus. See, this is something that a lot of students may think that, okay, this is very simple. They don't need to care about this. But a lot of, you have a copy of the notes. Then can you take one each? Okay. A lot of students neglect this portion because they think that they will never see this. Okay, but the truth is a lot of times your questions will be phrased or they will be formatted in this form, whereby you must be able to tell that this is a quadratic equation. And first thing, when it comes to an equation like this, it tells you the shape of my quadratic graph. So how? You look at the coefficient of x squared, which is a. So think about it like this. If your coefficient is positive, when you are positive, you are happy, and that means you will have a smiley face. So your graph will be in the shape of a smiley face. And you don't just stop here and tell me that, yes, this is a smiley face. Because when your graph is a smiley face, it also tells you that this is a minimum point. So this is the 2 things that you can derive by looking at the equation you are given. Naturally, when you are negative, you are sad. Therefore, you will have a sad face, which means you have a maximum point. Okay, so that's the first thing you need to identify from your graph. Okay. Second things are your y-intercept and your x-intercept, which I think is a very straightforward thing, whereby you let x to be 0 and you let y to be 0 for the other side. Okay. Have you collected the materials? Can you take one copy each on the table over there? Okay, just give me a minute. Okay, so students online, I just sent the link for your notes and your mock exam, so you can click the link and download the file. Okay, moving on. Now you are to determine your maximum and minimum value. So why do we need to do this? A few things. Sometimes the question will ask you for the maximum value or the minimum value. If not, they will be asking you to plot the graph. So when you plot the graph, the requirements you have to read from the question. Usually they'll include the turning point, which means you must find out for me what are the coordinates of your minimum and maximum. If not, you have to add in your x and your y-intercept. So from here, okay, one method you can calculate your maximum and minimum point is your complete the square. Okay, completing the square tells you your maximum and minimum point straight away. So how do I do that? We look at our first example, okay? So let's say I have an equation over here whereby it's x squared plus ax plus B, for example. Okay. If we have this particular example over here, and they ask us to find for me your turning point, what you need to do is go and complete the square. Okay. So the steps in the notes is on the next page, but I want to go through together in the class first on how to complete the square, because this is the most important thing, and this is what most students forget. Okay, for those that are taking A-Math, this is also very useful. Why? I'll explain in a bit. So first thing first, when you complete the square, I want you to take note, you only need your x square and your x. Your constant is actually not necessary when you complete the square. Okay, it is just part of the equation which you must add in at the end. Second thing to note is that you only can complete the square when your coefficient of x squared is 1. So if it's not 1, you must factorize. And like I said, you only need your x squared and your x to complete the square. So you just need to factorize out from x squared and x. So from here, you have x squared plus ax plus, okay, your coefficient of x divided by 2, which means you will get a over 2 squared. Okay, and once you have this step, okay, you're almost there. But one thing that you must remember is you cannot change the value of the equation. No matter what math questions you're doing, no matter which equations you're doing, you cannot change the equation that they have given you. So if what they gave you is x squared plus ax plus b, you must make sure your final value is also the same thing. Okay? So if you were to add a over 2 squared, you have to subtract away the same exact thing, so that this portion over here gives you a net value of 0. And with that, your value didn't change. And of course, there's a plus b at the back. And then afterwards, this is the important part, okay? When some students, when they do complete the square, they don't understand what they're doing. They just follow the methods, okay? And today, I'm going to show you what this means. Why are you doing this particular step? These 3 terms over here, what they actually give you is your a squared plus 2ab plus b squared. And this is your special identity, whereby it is your a plus b squared. Right? So if you were to compare what I have in blue and what I have in red, x is essentially my a, 2ab is essentially my ax, and a over 2 is essentially my b. So from here, what you will have is you are able to convert into your special identity, which is a plus b squared. So from here, you are then able to have x plus a over 2 squared. This is for my complete the square portion. And of course, the remaining 2 terms at the back, you have to evaluate them. Okay, so evaluate the 2 terms at the back and get a squared over 4 plus. So your first 3 terms, this is what we call complete the square. Okay, and we are making use of our special identities a plus b squared. Okay, and also one thing to take note of is when you want to take the coefficient of x divided by 2 in this particular bracket, you have to take into account the sign. So if it's a negative ax, this has to be a negative. Okay, so this is what students will often miss out on, so take note. Then afterwards, from here, why do I say complete the square tells you your turning point? Okay, very simple. First thing first, we look at this equation. Let's say we complete the square and we have an equation like this. Okay, something like this. So yeah, I'll use -4 instead. Okay, so let's say we have an equation like this. Okay, first thing first, you must identify, is it a minimum or maximum point? So when we look at the coefficient of x squared over here, you get a smiley face, which means you will get a minimum point. So when you have a minimum point like this, what you are looking out for is your minimum value of y. Right? Have you collected the materials? You need the class notes for the right side. Okay, so what you're looking for is your minimum value of y. If you're looking for a minimum value of y, the first question you ask yourself is, how do I make sure this equation is my smallest? This has a square to it. The moment something has a square to it, can it ever be negative? No, right? So what's the smallest value a square can ever be? Anybody can tell me? 0, thank you. So the smallest value this square can ever be is 0. So you want this to be equals to 0 such that you get the smallest value. And for this bracket to be 0, x has to be equal to 2. Okay? Are you okay at the back? So when x is equal to 2, your bracket is 0. It essentially means that y is equal to 0 minus 4 to give me negative 4. So from here, you're able to calculate your coordinates of your turning point, which are 2, negative 4. So the idea here is very simple. You need to make sure that you can find the smallest value for this perfect square because there's a square applied to it. Which is why I say when you complete the square, it actually tells you a lot of things. Okay? The same concept will apply to maximum point. Okay? For maximum point, your equation will have a negative in front. So this is for min. Now, let's say I write for max. Y equals to negative x minus 1 square plus 4. Okay, something like this. Okay, so we all know that when we have this equation, this is a maximum point. Instead of writing it in this form, you can actually rewrite into 4 minus x minus 1 squared, like this. And then afterwards, ask yourself, if you want the highest value that this can ever be, you should be subtracting away the smallest value away from 4. This is how you can obtain the maximum value. So you want your bracket once again to be my smallest value. Right? And same thing, for a square to be my smallest value, it must be equals to 0. So therefore, x has to be equals to 1. And y will just be equals to 4. So this is the reason why you complete a square when you want to find the turning point. Okay? Okay, moving on to our next page where we talk about our factorization of quadratic equations. There are 3 known methods that you learn in Sec 3. Okay, first one is your factorization whereby you find your roots, which some of you will use the table method like this or this tic-tac-toe method, either one. At the end of the day, I hope all of you know that you don't have to go through all this, right? If you realize if you've been doing all this method, if the equation is very complicated, you take a very, very long time to find the perfect combination, right? So how do you do that? Very simple. The calculator can help you with that. Okay, I'm not sure if all of you know, some of the students are not taught this in school. So in your calculator, if you are using the same material, same calculator as me, just need to click mode 33. If you are using the other one, it will be menu 522. Okay. So once you have entered the menu 522 or mode 33, what you will see is something like this, right? You have A, B, and C at the top. And if you recall, this means your coefficient of x squared, x, and your constant. So from here, all you need to do is key in some values, like for example, 1, 1, and negative 2, something like this. So let's say my equation was x squared plus x minus 2 equals to 0. You will be keying in 1, 1, and negative 2. Okay, so when you try that, you will realize that what the calculator shows you is 1. X1 is equals to 1. So x1 is equals to 1. The other one will tell you that x2 is equals to negative 2. I want you to bear in mind, when the calculator do this, it's not factorizing, it is solving the equation for you. So when the calculator is solving the value for you, it is telling you that when x is equals to 1, your equation will be equals to 0. And when you factorize, you will get 2 brackets. So what must be inside the first bracket? It must be x minus 1. Because when x is equals to 1, 1 minus 1 gives me 0. Then for the other example, it has to be x plus 2. Because negative 2 plus 2 gives me 0. Okay? So this portion over here, this is how you make use of the calculator to factorize for you quickly. So instead of going through one by one and finding all the possible combination, this can tell you what is your factorization straight away. So make use of this in the exam. Okay? And of course, when it comes to factorization like this, the 3 special identities that you must know from Sec 2 okay, will remain the same, which is your a plus b square equals to a square plus 2ab plus b square, right? And your a minus b square, a square minus 2ab plus b square. And last one, your a square minus b square equals to a plus b, a minus b. Okay, this one you learn in Sec 2, right? So you should be using them because it will follow you throughout all the way until O level. And question, can I factorize this? Can I factorize a square plus b square? No, I can't factorize this. Okay, a square plus b square is something that I cannot factorize. So I have some students that will tell me a square plus b square is the same as this, but it's not the same. So please take note. Okay. Second formula that you will learn when it comes to solving quadratic equations is your quadratic formula. So when do you use this? Very simple. Use this when you cannot factorize. This is the first scenario, right? If the question asks you to solve a quadratic equation and you cannot factorize with the calculator, cannot factorize with the calculator meaning to say when you use the mode 3-3 method, what you see is a decimal. That means you cannot factorize. Then you use quadratic formula. Second is when the question say, leaving your answer in 2 decimal place or any decimal place or significant figures. When the question says solve this equation, leaving your answers to 2 decimal place, is a sign to you that you must straight away use quadratic formula. So never ever use your mode 3-3 or calculator to solve when you see this portion over here. Last thing to note, which is really the most obvious one, if your question gives you 3 marks for solving a quadratic equation, just ask yourself, do you think you'll be given 3 marks for keying calculator? No. So that is a sign for you to use your quadratic formula at the same time. Okay. One thing to note, your square root cannot be negative. So in the event your square root value inside is negative, it just means that there is no solution. Okay. Last one is you're completing the square, which I have briefly went through already. So the method for you over here, once you complete the square, you must be able to use it to solve. A lot of times in your exams or in your questions that you see in exams, they will ask you to complete the square and they'll say, hence solve the equation. Hence means you must make use of the previous part. So if you don't use the complete the square version, you will not get a full marks, even if your answer is correct. Straight 0 because of the word hence. So take note of how to make use. You need to shift all your constants over. So in the event you get maybe x minus 2 squared minus 16 equals to 0. Okay, you want to solve this equation, you bring 16 over, and then you square both sides, right? Because take note, your idea here is you want to solve for x, which now is trapped inside this square root. So if it's trapped inside this square root, what you need to do is remove the square root by square rooting both sides. So you will get 4 or negative 4. This portion over here, remember, there is always a positive and a negative. Then from here, you will solve for x. So x will just be equal to 6 or negative 2. Okay? Okay? Afterwards, last one before I move on to what example questions, okay? When you want to sketch a quadratic graph, when it comes to your graph, okay, I want you to know that you want to find your turning point. Let's say you have your 2 brackets, x minus 1 and maybe x minus 3 equals to 0. From here, technically, you know that your graph will have the x-intercept of 1 and 3. And then now the question is, how do I find my turning point, right? Turning point is always the midpoint of your 2 x-intercepts. Because turning point lies on a line of symmetry. Line of symmetry means what? If let's say this is my line of symmetry, when you flip the left side over to the right side, you must get the same exact shape, which means my length here must be the same. So therefore, your turning point has to be the midpoint over here. And how do I find midpoint? Midpoint is like finding your average. And I'm sure all of you know how to find average. It will just be 1 plus 3, 2 to give me 2. So therefore, x is just equal to 2. And of course, the moment you know what's x, you can find what's y easily by using your equation. Okay, so your line of symmetry, This is known as my line of symmetry. Okay, it will always lie on your turning point. Okay. And one more thing, when we talk about your complete the square, okay, now I have a minus 16 equals to 0. In the event I have a plus 16 equals to 0, and the question asks you to solve this equation, do you think it's possible to solve? Just by looking at this. Why not? Very good, you can't square a negative number, because for this equation to be 0, it means that this must be negative, which is not possible. So therefore, there's no solution. Another way of explaining this in the exam, if they ever ask you to explain, complete the square tells you what? The first portion of my lesson, what did I cover? Completing the square tells you your... What does it tell you? What does complete the square tell you? Sorry? It tells you your turning point. So in this case, we know that my turning point is a minimum value, and my coordinates will be negative 2, 16. This is your minimum point. Meaning to say, your graph, when you draw a smiley face, the lowest it can ever go is at negative 2, 16. My y value is 16. If my lowest value is at 16, do you think there will be a point whereby my graph touches the x-axis, whereby y is 0? No. So that is another explanation that you can consider by saying that the minimum point is above the x-axis, therefore there's no solution. Okay, so you have these two methods to go and explain why is there no solution for specific quadratic equations. Okay, so now let's move on to our example question 3. You have 3 examples for your quadratic equation question. And then, so we look at the first question over here, right? You are asked to complete the square in the first portion. So first portion asks you to complete the square. What you need to do is to follow the steps that I said just now. So can I move on? Part A, you have your x squared plus 16x minus 30. So from here, you just need your first portion. So x squared plus 6x plus 16 over 2 squared. Then you must subtract away the same exact thing, followed by minus 30. So these first 3 terms will tell you what is my complete the square, which is your x plus 8 squared. So always evaluate your fraction, unless it will not get a whole number. Then you don't need to evaluate. Then simplify the portion at the back by using calculator, and this will give you minus 94. So this will be my complete the square version.
And then you need to show like, okay, you just click.
Yes. This is the bare minimum. You just need to show this. You must at least show this portion where you add and you subtract. How you get x plus 8 don't need to show. How you get minus 94 don't really need to show. Okay. So from here, I ask again, when you complete the square, what do you tell straight away from completing a square? Turning point, very good. So from here, you will tell what's the turning point straight away. Okay. So let me just put at the side over here. My turning point, my minimum point will have a coordinate of negative 8, negative 94. Okay, because part C, we asked to sketch the graph. Part B asks you to solve the equation, giving your answer correct to 2 decimal place. Usually when you see correct to 2 decimal place, which method must you use? Quadratic formula. But now this question, there is a keyword in front called hence. So if you use the quadratic formula, 0. You must use your previous part, which is complete the square, which you have already done here. So what you can write down for me is x plus 8 square is minus 94 is equals to 0. In other words, x plus 8 square is just equals to 94. Okay? And then from here, x plus 8, when you square with both sides, you will get plus minus root 94. Which means x will just be equals to root 94 minus 8, or negative root 94 minus 8. which will give you an answer of 1.70 or negative 17.70. Two decimal place. Okay. So don't need to be too worried if your part A is wrong or if you don't know how to complete the square. As long as you use your previous part to answer this question correctly using the correct steps, you will still get the marks because of ECF. Okay, so just try and complete the square and use what your answer is in the previous part to solve part B. Wrong, never mind, there's ECF, as long as your method is correct. Okay, then afterwards in the exam, when I was a student, I was very kiasu. I want to make sure that I get all my questions correct. So how do you check your answers? You're solving for the equation, right? What equation am I solving for? This one. Can the calculator solve this for me? Yes. So check the calculator and you must see the same exact answers to two decimal place. Okay. In the exam, these kind of questions, 2 to 3 marks, depending on how generous your school is. So is it worth checking for the 10 seconds? Yes. Okay. Part C asked me to sketch my graph showing my turning point and my y-intercept clearly. So take note. If the question didn't say x-intercept, even if you don't put your x-intercept, you won't get deducted any marks. So take note of the instructions in the question. They say y-intercept. Okay, so y-intercept means x must be equals to 0. So y will just be equals to negative 30. Okay, how do I know straight away? Because I look at this equation. When x is 0, everything else is 0 except negative 30. So from here, you will have your y-intercept to be negative 30. Your turning point is at negative 94 and negative 8. And since part B, we have already solved for your equation when y is equals to 0, that means you technically also know your x-intercept. So let's just plot in the x-intercept as well, even though the question didn't require. So you have 1.70 followed by negative 17.70.
Sketch doesn't skew it.
No, it's fine. As long as you, what I'm saying is you don't need to be exactly like, okay, 1 cm, 1 cm, 1 cm. But you cannot be too ridiculous whereby you tell me this is 1.70 and afterwards you tell me this is negative 2. Like, no, this kind is too much, cannot. Okay, but don't need to be too accurate, but just you cannot have it to be too exaggerated. Then from here, once you have your points, you cross out these 4 points, connect the dots and sketch a graph. So your graph over here, I know some of you are worried that your graph are not very nice. You take a look at my graph here and you tell me, is this aesthetically pleasing or not? It's not. At the end of the day, this is not an art class. As long as you get the shape, which is a curve, as long as you make sure that there is no point lower than your minimum point, and as long as you make sure that your curve cuts through all the points that you draw, you are good to go. Don't need to be too worried about your graph. Okay? Okay, as you draw, let me just continue on my exam tips that I always give my students. Another tip in the exam, some of you like to erase your graph, right? And when you erase your graph, you realize your axis also erase, your intercepts also erase. Your intercepts and your axis you can draw in pen, it's fine. Only your graph draw in pencil so that you can amend your mistakes. Okay, so that you don't waste time rewriting the same thing over and over again. Okay, can I move on to the next question? Everybody feeling so far, right? You got any questions you must ask. Okay. Moving on to second work example, you must complete the square again, once again for part A. So you have y equals to negative x squared minus 6x minus 10. Then afterwards, you must start completing the square. And remember what I said just now. For you to complete the square, your coefficient of x squared must be 1. Now my coefficient is negative 1. So you must factorize out first. Factorize out the negative sign and you'll be left with x squared plus 6x. Like I said, you don't need the constant to complete your square, so you can leave it alone. But of course, if you want to factorize out from the negative 10, go ahead. Just that you must remember to put the negative sign back at the end. Okay, what I mean by that, you will see in a bit. So same thing. Now can the class contribute to how to complete the square? What's the next step? Last what? There's only 9 students here. I can just pick a random student. Okay, there's only one boy in this class, so the boy will answer first. 6 over 2 square, very good. Then afterwards, followed by, not you anymore, one more person. The next one very easy already. Thank you, minus 6 over 2 square. Okay, what's the purpose of this? You must make sure that you don't change the value of the equation. Okay, then afterwards there's a minus step. So from here, okay, for this example, I won't skip too much steps. Okay, I want to show you how to do your expansion properly. So from here, what you will get is your x plus 3 square. That's the first thing. Inside your bracket, you can simplify with the calculator. 6 over 2 is 3, 3 square is 9, so minus 9. Minus a 10. From here, you realize there is a big bracket, which is essential because at the start, you realize that you have a bracket inside a bracket. So you must have a big bracket. So from here, you open up the bracket, which means this negative sign applies to everything inside the bracket, which means negative 9 becomes plus 9 minus 10. And therefore, your final answer will be negative x plus 3 square minus 1. Okay? Same thing if you're very kiasu like me in the exam. If you want to make sure you secure every mark you get, right? How to check your answer? Very simple. When you go from your question to your complete the square, is it the same equation? Is it the same equation? Did I change the equation? No, right? So if I expand this, what do you think I must get back? The question. So if you got ample time in the exam, you go and expand. You don't see the question, means you're wrong. Go and redo. At least you know some marks you can save. Better than some topics you cannot save at all because you can't check. Okay? So this is for part A. Okay, part B asks you to sketch the graph whereby you must indicate the coordinates of the point whereby the graph crosses the y-axis and a turning point. Same thing from here, you can tell me your turning point straight away. But in this example, is it a maximum or a minimum? Minimum. Why minimum? Which is negative? What is negative? This one over here? The x square. X square is negative, which means what kind of face will I be drawing? Set face will be a maximum point. Okay, so remember to identify the shape first, then go and visualize this in your head. If not, you can always draw it out, it's fine. So you will have a maximum point, which means you will have negative 3, negative 1 as my coordinates. Okay. So that's your turning point. Then you want your y-intercept. So that means x must be equals to 0. So you let x to be equals to 0, meaning to say y will just be equals to negative 10. So therefore, you will get 0, negative 10. So remember why we need to identify the shape, because it tells you whether it's a min or max and also tells you the shape of the graph. So that when you plot, you will know what is the shape you must draw. So once you have this, identify negative 10 followed by your turning point negative 1, negative 3 is over here. So now technically in this graph, you only have 2 points to plot, but at least you know it's a set face. So you can just do a rough sketch. As long as you make sure that there is no point higher than your highest point and you make sure that you cut through the y-intercept, you will get the full marks. Okay, for part C, you want to explain without solving why there are no solutions. This is what I mentioned just now. There are 2 methods that you can consider. The first method that you can consider is when you say that the highest point, rather the maximum point, is below the x-axis. Therefore, there is no intersection with the y-axis, with the x-axis, so there's no solution. Okay, because the highest you can ever be is already below the x-axis. So there is no way you can ever touch the x-axis. Your second method is you use your your complete the square. And from here, this will tell you that negative x plus 3 square must be equals to 1, which means x plus 3 square must be negative 1, which is Not possible. You okay? Your question? Your question must ask. Nobody here. Just imagine there's nobody here, it's just me and you. Okay? So from here, square cannot be negative. So therefore, there's no solution. This is the two methods. Okay? Okay, last one, example 3. Okay, example 3, you have the curve. So now for the first time, you don't need to sketch a graph anymore. They will tell you what's the curve, right? Then afterwards, they will give you the question. They ask you to solve for the values of P and Q since you have the equation. Okay? So when we look at this question, it is not like the questions that we've always been doing because we are not completing the square. We're not doing anything, right? You only have the graph and you have the equation. But the equation we have is in the form of complete the square. Once again, can the class tell me, when you complete the square, what do you know straight away? Turning point, thank you very much. Okay, so your turning point, which in this case is a minimum, has a coordinates of P, Q. Then you must be wondering, why am I looking for this? Okay. Remember, your turning point lies on the line of symmetry. And these 2 points that you are given, they form a horizontal line. Okay, and this is not because I assume, it's because the y values are the same. Y values are the same means you get a horizontal line. So this is not an assumption. So if you have a horizontal line like this, it means that your line of symmetry will be equidistant from these 2 points A and B over here. So somewhere around here, this will be my line of symmetry. So that when you flip your left side over, you will be at the same exact point at y equals to 7. And we also know that line of symmetry passes through your turning point. So from here, line of symmetry is like finding the what? Average of my 2x values, which are -2, 4. So therefore, you want to find your x coordinate of your minimum point. It will just be -2 plus 4 divided by 2 to give me 1. So this is for x. So it is for x, right? Which means it will be for p, because p is my x coordinate of my turning point. So therefore, p is 1. Then afterwards, how to find q? When you have p, you can rewrite your equation into y equals to x minus 1 square plus q. Do you have a coordinate on this point, on this graph? Do you have a coordinate on this graph? You have, right? 2, -2, -7, and 4, -7. So what you need to do is to sub in the values. Let's say you sub in point A, you will get -2 minus 1 square plus q, which means you will have 9 plus q equals to -7. Q must be equals to -16. Finish. So q is -16, p is 1. That's how you answer a question like this. So remember, when you see a question like this, a lot of students panic because this is not what they usually see. What they usually see is complete the square, then you sketch. Now they reverse psychology rule. They give you the graph. They ask you to tell me what are the values. So do not panic in the exam. Go and remember what can you deduce from your coordinates. How do you find a line of symmetry? How do you link it to your complete the square? Then they will either give you an x-intercept or they will either give you something like this. You must also remember, they cannot test you on something you cannot solve. So but the questions definitely can be solved. It's just which way you consider. Okay, the easiest way is always look for the line of symmetry. If not, they will either give you maybe your y value of your turning point or your x value of your turning point. Then from there, you can solve the equation. Okay? Okay, but that's a very good question over there. But like I said, don't need to worry. They will not test you on something that you cannot solve. Okay? So from here, you have y to be equals to x minus 1 square minus 16. So if this is equals to 0, because you are looking for x-intercept, it just means that x minus 1 is equals to plus minus root 16. Okay, because you just shift the 16 over. So therefore, x minus 1 is equals to 4 or -4, which means x is equals to 5 or -3. Finish. That's it. Okay. Okay, moving on to our next chapter, which is our similarity of 3D diagrams. Okay. First thing first, you want to ace this chapter, you need to know how to find your area volume of all your figures. Cone, pyramid, prism, cylinder, all on this. Okay, and if you remember, or rather if you have done practice papers already, you realize that the formula sheet tells you your volume of a cone, tells you curve surface area of a cone. So that's one thing you don't need to memorize. Sphere, same thing. But things like pyramid, no, you're not given. So how do you find the volume of a pyramid? 1/3 times base area times height. Okay. Sorry, for Swadin, right? I will send the annotated notes to the class later. Okay, so you will see. If not, you can just drop me a message now on Telegram. I'll just send you straight away. Let me just send my Telegram username inside the chat. So anybody want to send me a message, you can just send me a message. Okay. Okay, moving on. So this is for volume of pyramid. Right? So sometimes you'll be asked to find the volume or whichever formula that you're knocking off. So you have to go and know. Then afterwards, when you talk about similar figures, remember, don't have to prove that they are similar when it comes to 3D figures. Because what you're tested on is just when there's a small cone inside a big cone, or a small cylinder compared to a big cylinder. The moment you see that they are both cylinders or they are both cones, it means that they are similar. So don't need to prove. Okay? Then afterwards, you must realize when you talk about congruency and similarity, if two diagrams are similar or two figures are similar, your lengths will have the same ratio. So L1 over L2, right? So this will be your ratio of your corresponding lengths. And then if you want to remember how to find the ratio of area, just need to ask yourself, area is in the units of cm squared. Length is in the units of cm. To go from cm to cm squared, what must you do? Square, finish. So if you square your units, you of course square the fractions, which is how you derive this particular equation over here. They must be similar.
Like any shape.
Yes. Yes. As long as you know the corresponding ratio of the length. Okay. Keyword here is what? Ratio. Okay. Yes. Any shapes that are similar. So they must be corresponding. So if you are using the radius of the first circle, you must use the radius of the second circle. So this ratio over here, take note, we always emphasize on corresponding because you cannot randomly take any lengths you like. Okay. So naturally, when you want to go from length to area, you square. Right? When you want to go from length to volume, you cube. The reasoning is the same because volume is what? Cm cubed. So you look at the units, which all of you will know. That's you remember what must you do. Either you square or you cube. Then the next question where most students will always make a mistake in. Very simple. Now let's say I tell you, my area of B to my area of C is 8:18. This is my ratio given for my area. And they are similar figures. Okay, let's say they are similar. Some students will tell me, okay, if I want to go from length to area, you square. From area to length, what do you do? Square root. So what they will do is what? Square root 8, square root 18. Your all press calculator, square root 8, what do you get? Same for square root 18, what do you get? You get a decimal, right? And when you get decimal in the exam, what will you do? You will panic. Okay? Confirm panic. So what? So what am I talking about? Because this question says is the ratio. Is this ratio 8/18 in the simplest form? Is it in the simplest form? No, right? So you always simplify in your calculator, which will give you 4:9. Now you square root, what do you get? You will get 2:3. So can you see that just because you simplify, you're able to get a nice number. And you compare it to a decimal that you see just now, you don't want. So the working that you press in the calculator is very simple. To derive this, you press square root 8/18. You will still see the same thing because the calculator will simplify for you. This is where students always make mistakes. They forget that what they are working with are ratios. So you must always use the calculator to simplify. Okay? And when I say this, I'm not saying that your school will never test you on decimals. Okay, there is a chance that there will still be a decimal. But at the end of the day, there's nothing to panic. There's nothing to panic about as long as you have checked that the ratio is its simplest form and that you have cube root or square root correctly. Okay. Okay, so for volume, same thing, you just need the cube or cube root. So when we talk about this, let's say now you have not a very nice number, or rather, let's say your volume of A to my volume of B is maybe 2:16, something like that. Okay, and they tell you that my length of B is maybe like 4 cm. Then you must find the length of A. You look at this, then afterwards, okay, no, sorry, not 16. I want to choose an ugly number, so 15. Okay, so let's say your ratio of volume is 2:15. You want to find a length. When you want to answer a question like this, if the question is asking about length, you must find for me the ratio of length. Then how do I find the ratio of length? Cube root, right? So when you cube root your ratio of length, LA over LB, you will have cube root of 2/15. And when you press this in calculator, it's a very ugly number. So is there a point in pressing calculator? No, you can always leave in exact. So what does it tell you? It tells you that my length of A is cube root 2 parts. My length of B is cube root 15 parts. And the question has given you what is the length of B. So technically, you know what is cube root 15 parts equals to 4 cm. So if you want to find the length of A, it will just be cube root of 2 over cube root of 15 times 4. Finish. Then you press calculator, then you get the final answer, 3SF. Okay? So take note, use the ratio. Okay? Then of course, if you really see a decimal, it's fine. You write it in this form, you won't see decimals already. Only your final answer, you will see a decimal. Okay? At any point, if you're all hungry, let me breakfast, one chips. Maybe to take in front. Okay? Okay, moving on to our first word example. We take a look at your question number 4. Okay? This question over here gives you a piece of wood that is in the form of a right circular cone with a diameter of 18. The curved surface area of a cone is 135 pi. Can anybody tell me what's the formula for curved surface area? Nobody know? It's fine. Don't need to know because it's in the formula sheet. Okay? So your curved surface area is pi RL, whereby L is my slanted height of a cone. So for a cone, you have to break it down into a perpendicular height, which is known as H, and the slanted height, which is known as L. So pi RL is equal to 135 pi. Cancel the pi and you will get RL. The question gave you the diameter to be 18, which means my radius has to be 9. So 9L is equal to 135. L must be equals to 15. So I have L to be equals to 15. Radius to be equals to 9. Then from here, how do I find the height? Can somebody tell me? How do I find the height? Pythagoras theorem, very good. So by Pythagoras theorem, which by the way, you must still write, even at Sec 3. Okay, so by Pythagoras theorem, H is equals to square root of 15 square minus 9 square to get 12 cm. So that is my height of my cone. Yes, when you want to prove, you use converse of Pythagoras theorem. Okay, second part, the cone is cut into 2 portions with a horizontal cut. The upper portion is a cone, the lower portion is a frustum. So what's the frustum? Is this ugly looking shape over here, whereby you remove a small cone from a big cone, you will get a frustum. So to illustrate what the question is doing, I'll do my best to draw this diagram out. But as you see from my curve just now, I'm not a very good artist. So let's say this is my big cone. Okay. You cut away a small cone at the top over here like this. So your remaining is your frustum, which is this portion over here. Okay, the diagram okay, right? Okay, then afterwards you look at what the question is saying, right? This frustum has a height of x. And my diameter of my small cone at the bottom is 6. My diameter of the big cone at the bottom is 18. So when we talk about cones, small cone, big cone, are they similar? Yes. So therefore, do I know what's the corresponding ratios of their lengths? Yes. How do I write down? You want to present this, you have length of small cone over length of big cone equals to 6 over 18 to give me 1 over 3. So what does that mean? The big cone is 3 units. The small cone is 1 unit. Then where does the remaining 2 units go to? The frustum, right? Which is x. And do I know what is the height of my cone already? The big cone. From part A, right? Over here. So therefore, 3 units is equals to 12 cm. You're looking for x, so it's just 2/3 times x to be equals to 8 cm. Finish. Okay, I squeeze here so that I can draw the diagram, but you don't need to squeeze there. Okay, so even if, in this case, right, your frustum, you must remember, your frustum is not similar to my cone. So even if I know the ratio is 2:3, you cannot square it to find the ratio of the area. You only can square when there are similar figures. So take note of this. And the reason why this 2 units is really just total is 3, this is 1, this must be 2. Okay? Okay. Next question, your part C, last part. A right cylindrical hole of diameter 6 cm is drilled through the frustum as shown in the figure. The wood weighs 810 kg per meter cube. So from here, when we set this for our Sec 4 June crash course, everybody got this question wrong. Why? You look at the units, exactly. The unit that we have been working with is cm. Now this is what? Meter cube. So you either change the cm to meter first, or you change from cm cube to meter cube afterwards. But then my next question to you is, who here can tell me how to convert from cm cube to meter cube straight away? Nobody. Therefore, what's the easiest way? Divide by 100 cube. Yeah, divide by 100 cube. Right? So the easiest way is to convert from cm to meter first. Okay, so everything we're going to do now, I'll change to meter straight away. So first thing first, you must find the mass of the solid which remains in the frustum. You are removing this cylinder away from the frustum. So what do you need to find? You must find for me my volume of my frustum minus away my volume of my cylinder. So let's do the easy one first, the volume of the cylinder. Volume of cylinder is given to be pi r square h. Base area, which is a circle, times my height. So pi times, what is my radius? 6 divided by 2, so 3 cm, 0.03 square. I convert to meters already, so every time you see my decimal or my length, they are all in meters. Then what is my height? X, which is 8 cm, so 0.08. Okay, from here, this is where I share my exam tips once again. Okay, in your exam, I know you want to round off to 3SF as your final answer. But if you're working, you use 3SF, your final answer, there's a chance that it will differ by 0.01, which means you will lose your answer mark. Okay, so how do you make sure that you don't lose that 1 mark? Very simple, you write in 5SF. Then you use 5SF for your working. But now there's a pi, you can always live in terms of pi. So how to key this in calculator? Just press the number portion. So 0.03 square times 0.08 and you will get 0.000072 pi. Okay, in this case, a bit unlucky, the decimal is still quite long, but I'm pretty sure it is better than if we are using times pi straight away. Okay, so leave your answer in terms of pi first. At the end, then you go and evaluate. You have a question? Okay, next thing, we must find the volume of the frustum, right? But we don't know how to find volume of frustum. Nobody is taught on how to find volume of frustum. So what must we do? We go back to my ugly diagram just now. My frustum is derived from where? When I cut the small cone away from my big cone. So therefore, what I must do is to take my volume of big cone minus my volume of small cone. But we have to make use of I mean, no, we have to. I want to show you how to make use of my ratio of volume. So we know that my ratio, my length of my small cone to my length of my big cone is 1:3. Right? I hope you also remember because it's 6/18. So if you want to find your volume ratio, you must cube. So you will get 1:27. Meaning to say your cone has a volume of 1 unit, your big cone has a volume of 27 units. So what do you think the remaining 26 units go to? The frustum, exactly. So my volume of frustum is actually 26 units. So what I need to find out for me now is what is either my volume of small cone or my volume of big cone. So let me find the volume of small cone since I know what are the corresponding lengths already. It will just be 1/3 times base area, which is 0.03 square, times my height. So what's my height of my small cone? If the entire figure is 12, the bottom is 8, means the top must be 4. So 0.04. If you're wondering how I get these numbers, okay, this is my radius of my small cone, which is over here. My height is just 12 minus 8 because the entire figure is 12. So you take away the frustum of 8. From here, same thing, you multiply everything in the calculator by the number, you will get 0.000012 pi. So volume of small cone is this particular number over here, which is equivalent to 1 unit. We have concluded that the volume of frustum is 26 units. So you take 26 times 0.00012 pi to give me 0.000312 pi. So this is my volume of frustum. So you have the volume of frustum, you have the volume of cylinder. Can you find the volume of the remaining solid now? You can. Just take frustum minus cylinder. So volume of remaining solid. Okay, sorry, I cut your train of thought. When you work out this classroom today, you must want to solve this question. So if you've got any questions, please ask now. Because if not, for some of you, you wake up so early, you come here, then you don't learn the maximum, you wasted your trip here, right? So just make sure you ask if you have any questions, don't need to be shy. So 0.000312 pi minus 0. Okay, then afterwards, you want to find the mass in grams. So you must take 810 times 1000 so that you convert to grams, then you followed by times your volume, which will give me a final answer of 611 grams 3SF. Okay, take some time to look at this working. If you got any questions, please feel free to ask me. Just the question one's in grams, but the unit is in kg. Done? Okay. Next, move on to the next question. This particular question over here, I gave to my regular class and nobody could solve it because it was too difficult. But at the end of the day, what I want to say is they cannot test you what you are not taught. What are you taught? You can find the ratio of area of similar figures, right? So you need to find out for me what are similar figures. In this case, we're working with a cone. So where do you see a cone? The first cone is over here. The second cone is over here, this entire big thing. And the last cone is of course the big cone. Okay, so from here, okay, sorry, give me a minute. You read the question first. Let me answer this question. How do you obtain VF? Okay, sorry, let me go back to the question again. Okay, 1/3 is because my small cone is 1 unit over here. My big cone is 3 units over here, which is why it's 1:3, not 1:4. Okay, then how do I obtain the volume of frustum with 26 units? When you calculate the ratio of volume, you get 1:27, which means in my diagram here, the small cone is 1 unit, the entire big cone is 27 units, which means the remaining portion has to be 27 minus 1 unit to get 26 units. Does that answer both of your questions? Why do you times 1000? Because the question say they want in grams, but the units here is kg. So I times 1000. Okay. 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 Sorry, back to this question. So we look at the cones, right? You want to find the ratio of the curved surface area of A to the curved surface area of B. So A is not a cone, B is not a cone. So how? First thing first, I know my ratio of length. 2 is to 5, 2 is to 3 is to 5. This is for my length. So we want to focus on my ratio of cones because we only can use my ratio of similar figures. So first thing first, we're going to find for me my area of B plus C is to my entire cone. So B plus C gives me 8 units for my length because it's 5 plus 3, right? So what you will get is 5 plus 3 square is to 10 square because my cone is 5 plus 3 plus 2. So this will actually simplify into 8 square over 10 square. You actually get 16 is to 25. No, I simplify the fraction. So you take whatever, you take this over 10 square. Then it simplifies into 16 over 25. Okay, so what does that mean? It means that B plus C is 16 units for my area. The whole thing is 25, which means A must be 9 units. Okay, that's the first step. Second step is when you must go and find for me what is the volume of C. So you look at C and you look at the entire cone once again. So if you compare your C is to your entire cone, you will realize you get 5 square is to 10 square. So once again, you simplify your entire fraction, you will get 1 is to 4. Then afterwards, you realize, how come on the left, my cone is 25, on the right, my cone is 4? They are the same cone. If they are the same cone, your units must be the same. So from here, you must make 25 and 4 the same. So LCM is 100. So at the end of the day, simplifying at the beginning, so no use. Okay? So this is what you'll get. Which means A is no longer 9 units. Take note. Because if B plus C is 64 and the entire cone is 100, okay, from here, A must be 100 minus 64 to give me 36 units. And C is 25 units. So C is 25 units. And according to my formula here, what am I saying? I am saying that B plus C is equals to 64. So once I know what is C, can I find what is B or not? You can, right? It's just 64 units minus 25 units to give me 39 units. Then afterwards, how do you check whether your answer makes sense or not? A plus B plus C makes up your area of the cone. My cone is 100 parts. This plus this plus this must give me 100 parts. So therefore, A is to B will just be 36 is to 39, which simplifies into 12 is to 13. Okay, take some time to absorb this working. Why do you use B plus C and not B plus A or A plus? Okay, because we are focusing on your area of similar figures. Remember, for you to even use your square like that, the condition is what? The figures must be similar. So you only can use cones because we are working with cones here. If you were to use this portion, A plus B is not a cone. If you were to use A plus C, it's also not a cone. So we only can work with cones, which is why I have to use specific ratios. Okay, I square the values because I'm finding the ratio of area. The question gave me the ratio of length. To go from ratio of length to ratio of area, you have to square. Does that answer all your questions? Okay, very good. So now we look at part 2, the ratio of volume of A to the volume of the whole cone. So once again, A is not a cone. So I cannot use my ratio of ratio of volume formula whereby I cube the ratio of length because they are not similar. A is not similar to cone. So I must do what I did in the previous question just now. The entire cone is made out of A plus B plus C. B plus C is a cone. So therefore, if you want to find the volume of B plus C is to the volume of cone, B plus C is total of 8 units for my length. So to find volume, you must cube. So 8 cube is 2, cone is 10, so 10 cube. Same thing, simplify this entire thing into a simplest fraction. You will get 64 is to 125. This is not the final answer because your cone is 125 units. B plus C is 64 units. Then where does the remaining units go to? A. So therefore A is 61. How do I get 61? 125 minus 64. A cone 125 minus 64 is to 125. So that is 61 is to 125. Finish. Okay. So next question, the volume of A is 122 cm cube. Calculate the volume of B. So I must know what is volume of A, right? Because my volume A is 61 units, not 61 cm, 61 units. So therefore, in part C, 61 units is equals to 122. So what does that mean? 1 unit is equals to 2 cm cube. Question asks you to find volume of A. You must tell me how many units is the volume of B. Sorry, volume of B. Okay. So how do I find that? You know that volume of B plus C is 64 units. Is C in the shape of a cone? Yes. So can you find the volume of cone? Can. So when you compare the volume of cone is to the volume of, volume of C is to the volume of cone. C is 5, so it's 5 cube is to 10 cube, which simplifies into 1 is to 8. Okay? But what I have been working with is that cone is 125 units, right? So how do I find the volume of my part C in terms of the parts that I've been working with, which is 125? Very simple. 1 out of 8 times 125 units. This will give you the units for part C. Because my ratio of C is to cone is 1 is to 8. But cone is 125 parts. So from here, what you will get is 15 whole 5 over 8 units. So C is this, A is this, therefore volume of B will be 125 minus 61 minus 15 whole 5 over 8 to give me 48 whole 3 over 8 units. And since I know that 1 unit is 2 cm cubed, my volume will just be 48 whole 3 over 8 times 2 to give me 96.75 cm. Question. I hope you all are not blindly copying. Like I said, you come all the way here, you don't understand anything, you must ask. Then so that when you go home, you don't ask yourself what are you copying in this work paper. The 9 of you here who tried the mock paper. You all draw the graph. The red color portion, okay? Because we need to find the volume of B, okay? So B is not a cone, and we know that this portion over here at the top tells me that B plus C is 64 units. So therefore, to find B, you must find the volume of C first, then you take 64 minus the volume of C to find the volume of my B. Okay, so from here, C is a cone, which is why over here you can see that I simplify my ratio over here. Okay, does that answer your question? Okay, I hope so. Okay, now we move on to the last question. For students online, don't worry if you don't have the solutions or you didn't manage to copy it down. We will be uploading the full solutions, which I think will be this entire file over here. Okay, so moving on to question number 6. Just in case some of you still don't have the materials, Let me just resend it. This is my notes. This is the mock paper. Okay. Okay. Just ask me lah. Don't be scared lah. Okay. Part 6, question number 6. You have this solid formed by a hemisphere, radius r to a cylinder of height r. So the r here is the same thing. The other end of the cylinder is attached to a cone of height h cm. You must find the total volume of your hemisphere and your cylinder. So total volume, your hemisphere is given in the formula sheet. The sphere is 4/3 pi r cubed. So hemisphere must be half times 4/3 pi r cubed. Plus my cylinder is pi r square h. But in this case, my height is r. So therefore, it's r once again. Okay, so this one quite straightforward. From here, you will get 2/3 pi r cubed plus pi r cubed is equals to 5/3 pi r cubed. Okay. Second part, they say that the volume of cone is half the volume of the entire solid. This entire solid is made up of a hemisphere plus a cylinder plus a cone. So if this portion is half of the entire solid, the red color volume must be the same as my blue color volume. So therefore, my volume of cone will be given to be 5/3 pi r cubed. And how do I find volume of cone? 1/3 pi r square h. From here, you cancel everything that is common. R cubed, you can cancel into r. Pi r square is gone. The denominator is gone. So therefore, you will have h to be equals to 5r shown. That's it. Okay, I got one question for you all. Who here not tested on properties of circle in end of year exam? Properties of circle. So all tested So means all learned already, right? Part C, they tell you the volume of hemisphere is 54 pi. So hemisphere is given to be 2/3 pi r cubed equals to 54 pi. So therefore 2/3 pi r cubed is equals to 54. R cubed is equals to 81. So R will just be cube root of 81. Okay, same thing, you can leave this as exact answer. Don't need to evaluate. You want to find the volume of the whole solid. The question told you that the volume of the cone is half the volume of the entire solid. And the volume of cone is over here. So therefore, to find the volume of the entire solid, it will be 2 times 5/3 pi r cubed. And you already know the value of r cubed to be 81. So from here, you will get 270 pi, which evaluates into 848 cm cubed 3sm. Okay, if no problem, we'll move on to the last chapter already, which is your sector area radian measure. Any questions for the first two topics? If you all got any questions, you can always stay back later to consult me. If we end early, then okay, then don't need to stay back. Okay. Moving on to the next chapter on sector area, this portion over here. Okay, your formula over here, your up length and your sector area formula over here. Essentially, the concept that you're applying is your proportions. What I mean by proportions, very simple. Your circle, okay, let's say you have an angle at a point. Your angle over here at a point is 360 degrees. So 360 degrees covers the entire circle, which is your circumference, 2 pi r. If not, it will be your area of your circle, which is pi r squared. So what this means is, if 360 degrees is 2 pi r, how do I find theta degrees? Right? So that's why your formula is just theta over 360 times 2 pi r. So your concept here is on proportions. You understand this portion, when it comes to your area or length, you will know which is the correct formula to use. Because circumference of circle is 2 pi r, area of circle is just pi r squared. Okay? Then second part, when we talk about radian measure, you are taught that 180 degrees is equal to pi radian. Okay, so your formula here for arc length, when you are working in radian, you can actually make use of r theta and half r squared theta, which is given in the formula sheet. Okay, so from here, you will then have these two formulas when you're working in radian, but only when it is in radian. Take note, if it's in degree, you must use your proportions method. So look at the question and see whether it's radian or degree. Then afterwards, these two formulas are in the formula sheet. Don't need to memorize. Okay. So now we look at question number 7 on the next page, whereby the first portion talks about congruency. You must prove that two triangles are congruent. Okay. So bonus topic. First thing first, what I always tell my students, or what I've always done in the past, is when the question tells you to prove that this is congruent to this, it's a fact. You just need to prove it to me. Which means for congruent triangles and similar triangles, you must remember your corresponding sides must be equal, or the ratio must be equal. So how do you make sure that you always work with corresponding sides? You present, or you're working, you write like this. You will be able to tell straight away which is which. Like for example, if you're choosing OP, you know it's the first and the third letter. On the other triangle, you straight away will know it's O and Q. So then you will never ever make the mistake of having different sides that are not corresponding to each other. Okay? So from here, the question asks you to prove that OAP is congruent to OCQ. First thing you will know is that OC and OA, they are both known as the radius of the circle because it's from O to the circumference of the circle. And are they corresponding? Yes, because it's OA, OC. So therefore, first thing first, OA is equals to OC because they are radius. Okay. Next thing that you must identify for me now is this question said that AB is equals to BC, and AB and BC are known as chords. So right now, what we have here are equal chords. And a property of equal chords are what? Equal chords are equidistance from where? From the center. Very good. From the center. So what does that mean? It means that these two lengths are also equal to each other. But like I said, you must be corresponding. So just because they're equal doesn't mean you have to use it. So you must check. You choose O, the first letter. You use P, the third letter. Same thing. O, first and third letter. So therefore, you can conclude OP is equals to OQ. Why? Equal chords, equidistance from the center. This is a property that a lot of students neglect because in properties of circle, they only focus on the angle portion. Okay. Last but not least, okay, since they are equidistance and they are chords, the thing about chords is what? The question here said that P and Q are the midpoints, which means these two lengths are equal. All these lengths are equal, which means it's a bisector. And a bisector of a chord will pass through the center of circle. And does these two lines OP and OQ pass through the center of circle? Yes. But just now when I say bisector, it's because I haven't confirmed whether it's a perpendicular bisector or not. But now that I have seen that my both bisectors pass through my center of chord, it means that this must be a right angle. It must be perpendicular. So therefore, APO means on the other side, you must name it as CQO. is equals to 90 degrees because of my perpendicular bisector of chord. Passes through center. So it is a bit of a reverse psychology thing. Normally the property tells you that the perpendicular bisector of chord passes through the center of circle. That's where you draw and cuts the center. But now we don't know whether it's a right angle or not. But because we know that it's a bisector and it passes through the center of circle, that's why we can conclude that it's a right angle. Okay? So from here, you have a right angle. Your hypotenuse are the same. You have a side that is the same. This is what we call RHS. So therefore, triangle OAP is congruent to triangle OCQ because of RHS. Okay, RHS is what? You have the same hypotenuse, which in this case is OC and OA. You have one corresponding side, which is OP and OQ, and you have a right angle. So that is why we use RHS. So your properties of circle, these two are very rarely seen, but doesn't mean you can completely forget them. Okay, moving on. There's a typo here, this should be dead. So given that the radius of the circle is 6 cm, and the obtuse angle AOC is 7 pi over 9. So read the question very carefully. 7 pi over 9 is your obtuse angle, which is this portion over here. You must calculate the shaded area of the figure. So to calculate the area of the shaded figure, the safest method is to use your sector area minus away your triangle. Because you know that your radius is 6. So this is 6, 6, 6. Right? So sector area minus your triangle is the safest method. But to find the area of the sector or the triangle, you must first know what is these two angles. So what you need to do here is prove to me that angle AOB is congruent to triangle OCB. So what you need to write now is, okay, triangle OAB. You must go and prove this portion over here. Okay, you must prove this before you can assume that they are congruent, which means you can use the fact that the two angles are equal. The two angles in red are equal. So from the previous part, we already know that OA is equals to OC because from the previous part, they are congruent and also their radius, right? OB is equals to OB, which is a shared length. The last one is AB is equals to CB because they are equal chords. This is from where? This is from the question. The first one is because they are radius. So therefore, once you have proven to me these three identities, it means that they are congruent because of SSX. Okay, so I want to prove that they are congruent so that you can safely conclude that the angle here in red is equals to the angle here in red as well. So from here, you're able to find for me, okay, I'll put my working at the top for part B. You are able to tell me angle AOB is equals to 2 pi minus 7 pi over 90 divided by 2. Why 2 pi? Because angles at the point is 360. So you subtract away a 7 pi over 9, divide by 2, you will get one of it. And this will give you my 11 pi over 18. Reason being angles at a point. So once you derive that, you're able to calculate for me what is my area of one shaded figure. And they are exactly the same. So to calculate the total, just need to multiply by 2. So area, right, will just be 2 times of my sector area. And because now my angle is in radian, you can use your half r square theta. So half r square theta is 11 pi over 18. This is for my sector. This is for my sector. Minus away my triangle. Here I write at the bottom. What's area of triangle in this case? How to find the area of this triangle? AOB. If it's not right, a right angle triangle. Half AB sine C, very good. So you have half AB sine C. Then this portion, take note, because you're working in radian. When you key calculator, you must change to radian mode because it's sine radian. Okay, so when you key this in calculator, you will get a final answer of 35.3 3 cm square 3 cm. Remember to multiply by 2 in the beginning so that you can get the total, because what you are doing in the bracket is only for one sector, one shaded portion. Invested. Okay, moving on to the next question. Okay, sorry, hold on. Give me a while. I need to make sure that my laptop is charging. So I'll leave the screen here first so you can take a look at the working. Okay. Next question. What is OB equals to OB? Because we need to prove that they are congruent triangles. So OB is equals to OB. It looks a bit ridiculous, but you have to prove that step. I'm sure you have done this a lot of times already. Okay. So because we need to prove that they're congruent, so you must write down OB is to OB. Can I say that CQ is equals to AP? You can. Okay, you can say this. Okay, moving on to the next question. Next question, question 8. You have this figure semicircle diameter. You are given AB and you have a point C such that CAB is 24 degrees. You must find the area of triangle ABC. Okay, so properties of circle will tell you if this is a diameter, angle ACB must be a right angle triangle. Why do I want to identify a right angle triangle? Because in a right angle triangle, you can use your tuakaso. Very important, because if you don't use that, you cannot start. So you must write down for me angle ACB is equals to 90 degrees because of right angle in semicircle. So from here, you can do your tuakaso. So let's say this is my opposite adjacent hypotenuse. I will send the solutions at the end. Okay, we have to move on to the next question first. I'll send the solution at the end. Okay, or you can message me on Telegram and I'll send you. You are looking for either A or O. So let's say we're looking for A. You have cosine 24 degrees will be equals to AC over H, which is 8. So AC will be equals to 8 cosine 24 degrees. I don't need to evaluate first because once again, this is not my final answer. So you can leave it in this or you can leave it 5S, up to you. So once you have AC, you can straight away find for me my area using half AB sine C. Half times 8 times 8 cosine 24 times sine C, which is sine 24 degrees, which will give you 11.9 cm square 3S. Okay, this is for part A. But of course, like in part A, the triangle is the right angle triangle. You want to use the half times base times height also can, but means you must find what's AC and what's BC. So depending on which method you prefer. Now the question wants you to find the parameter of the shaded area, which means is this arc plus this length over here. Which means what we need to find out from it is this particular angle over here. So this is what a lot of students will forget. Because what they don't realize is that as long as you are from the center to the circumference of the circle, what is that called? From the center to the circumference of the circle, what's the length called? Radius. All the radius is the same, right? So if this is my radius, this is also my radius, which means I will form an isosceles triangle. So to find angle AOC, you will just take 180 minus 24 to give me 132. Base angles of isosceles triangle. You need your reasoning. So my angle AOC is 132 degrees, which means you can find for me your arc length and you can find for me your length AC. Right? So arc AC will be equals to 132 over 360 times 2 pi r, where my radius is 4. So this will give me 44 over 15 pi. That is for my arc. So all of you know how to find arc, right? The arc length formula, your proportions. Then afterwards, to find the length AC, which is this length over here in blue. Okay, a bit of trigo context is very simple. Every time you have a trigo question, ask yourself, is it a right angle triangle or not? If it is, you can use Pythagoras theorem and Tuaka. So if it's not, sine rule, cosine rule. So in this case, it's not a right angle triangle. You will use your cosine rule, which will be 4 square plus 4 square minus 2 times 4 times 4 cosine 132 degrees. So now you must change back to degree mode and we'll get 73084 EM for Python. Okay, so that's for length of AC and the arc AC. Then of course the last step is to add both together. And your final answer will be 16.5 cm GSF. Okay, so I believe you know how to write the working for the last portion. So your final answer should give you 16.5 cm when you add the length of the arc plus the length of the line AC. Okay? You copy from the printer. Okay, now for the last question, which is question number 9, I will give you all some time to shine. Okay, so at 11:40, I will go through question number 9. So from now to 11:40, please try this question. If you can answer this question, trust me, you can answer anything in this topic already. Okay, so same for online students, you can go ahead and try question number 9. I will go through at 11:40. Okay. Going through the. Okay. I think part A should be manageable for all of you. Part B is the tricky one, which I'll talk about it now. So for part A, question said that shaded area is equal to area of unshaded area. That means that this is 1 unit, this is 1 unit. So they're equal. So what you can find from this question is your area of sector, right? Which is given to be half r squared theta. So half times r squared times theta, which is pi over 3. So from here, what you will get is actually your (16 32 pi over 3). So from here, since they are equal, shaded is equal to unshaded, your shaded will just be equals to 32 pi over 3 divided by 2 to give me 16 pi over 3. This is for shaded. So for the unshaded portion, this is in the shape of a triangle. Okay? So if it's in the shape of a triangle, that technically you can find the area of this triangle by using your half AB sine C. So it's half times 8 times OC times sine pi over 3. So remember, now you are in radian mode, calculator must change to radian mode. Okay? If not, you can leave in exact if you remember what are your special angles. Pi over 3 is 60 degrees, which is considered a special angle, which is just equivalent to root 3 over 2. Okay, but if you keep calculator, you also get the same thing, so it's fine. So therefore, from here, you will get 2 root 3 times OC to be equals to 16 pi over 3. Therefore, OC will be 16 pi over 3 divided by 2 root 3 to give me 4.84 cm 3SF. Right? Okay, that's for first part. Quite easy. Second part, when we talk about the perimeter of the shaded region. Okay, wait, let me just. Okay, we look at the part B now. We talk about perimeter of shaded region, right? So perimeter of shaded region is made up of what? It's made up of my arc plus AC plus BC. So that is for my shaded. Okay, AB plus AC plus BC. This is for shaded. For unshaded, it is made up of 8 plus AC plus OC. So 8 plus AC plus OC. We are solving for OC. You look at the left-hand side, you look at the right-hand side. You realize that AC appears twice. So can cancel? Can. So instead of trying to find AC, when you write it out like this, you realize AC can be cancelled, which means you don't need to go through the trouble of finding what's the value of AC. Then afterwards, you want to find AB is just your arc. So AB, it will just be R theta. So it's 8 times pi over 3. Right, this is my formula for arc length, R theta. Then you have BC, right? But remember, you're solving for OC. So you want your equation to be in terms of OC. BC is this entire length minus OC. And this entire length is 8 because it's my radius. So therefore, it will be 8 minus OC. So this will be equals to 8 plus OC. Same thing, plus 8 can cancel. This, you shift the OC over, you will get 2OC equals to 8 pi over 3. So that means OC is equals to 4 pi over 3 to give me 4.19 cm 3SF. Finish. Okay, so you realize actually for part B, even though it looks a bit difficult, but the steps are shorter than your area. Why? Because as long as you list out which length makes up your component of your parameter, you'll realize that AC can be cancelled out. Where AC is the one that a lot of students will struggle with finding. Any questions? Any questions? Confirm. Okay, after I go through these 3 topics, I hope it will give you a better understanding on how to solve questions on these 3 topics. We will take a short 5 minutes break, then we will move on to mock paper. Anybody who haven't collected mock paper, please take from the first table in front. And for those who haven't tried, if you want to try now, you can go ahead and try. But we'll take a short 5 minutes break. At 11:50, we'll resume our lesson. Okay, and for those students online that are asking for notes, I will send you the entire notes when the class ends. Okay? And your one, please take it. Okay? Okay, all the students online, I will send this group chat link into the chat. You all can join the Telegram group. I'll send all the materials at the end of the lesson. So this is data. Okay. Let me start going through the mock paper now. Okay, so those online that wanna get all the materials, right? You can join the Telegram channel. I mean Telegram group that I just sent in the chat. Now we look at our mock paper, which is not that easy. Okay, but I hope you tried, and if you understand what I went through today, you should have no issues with the end of your examinations. First question is a rearranged formula question, which means at the end of the day, what you want is only a d on one side, nothing else. So first thing first, you will always see a fraction, and you don't want a fraction. So to multiply both sides by the denominator so that you don't have a fraction anymore. That is your very first step. You don't want a fraction. Okay, then afterwards, you want to make d the subject of the formula. So anything that has a d, you bring to one side, which means you can bring this over, or the other way around, up to you. So you will get cd squared minus d squared equals to 5 plus 3c. From here, you will realize that you only have d on one side and no d on the other side. But when you want to present this, you only want d equals to the blah, blah, blah. But now you have other things. So what must you do now is you must factorize, and you will get c minus 1 equals to 5 plus 3c. Okay, it is very common that you must factorize out the subject of the formula so that you can isolate it, meaning to say you can bring your c minus 1 over, and then you will only have a d square on the left, but the question wants d, therefore you must square root the entire thing. But if you write this as your final answer, you will only get 2 out of 3. Can anybody tell me why? Plus minus, thank you. You must include the plus minus in an example like this. Okay? Any questions? Correct? Correct. You all want the annotated notes later? Yeah, okay, then I will send the link. Okay, moving on to the next question. Okay, next question, you must express a single fraction, which means the concept here is you must have the common denominator. So common denominator, then you can combine into a single fraction. Now you have a x minus 2 and a 2 minus x. So you want to make sure that the denominator is the same. You realize that x minus 2 and 2 minus x, the main difference is a negative sign. So instead of writing 2 minus x, what you can do now is factorize out the negative sign. So what you will get is negative x minus 2. Then the question next is, where does this negative sign go to? It goes to the sign in front, which was originally a negative. So that is why negative negative becomes a positive. So this negative sign will be gone. So this is how you transform from a 2 minus x to x minus 2, by factorizing out the negative sign. Then from here, you just need to make the denominator the same by multiplying by x minus 2. So you will get 1 plus x over x minus 2 squared. Finish. That's it. Okay. The key here is to make the denominator the same. So you must make your 2 minus x look like your x minus 2. Okay, only for a question like this whereby you see the difference is a negative sign, meaning to say x minus 2 is the same as negative 2 minus x. Only like that, then you can factorize, right? But if it's a x minus 2 and x plus 2, there's nothing you can do because you can't make them the same. You can't take out anything from x plus 2 to turn it into x minus 2. So only when the two equations are separated by a negative sign, then you can do what we did in this question. Okay, moving on to the next question, simultaneous equation. I think this one, we don't need to talk much about it. There's only two methods, substitution or elimination. In this case, you can do either methods. So let's say we do substitution from the first equation. You are able to conclude that 5x is equals to 14 minus 3y. So x is just 14 minus 3y over 5. Then now afterwards, you will sub back into my other equation. And you can solve for here. You only need to show the working after this. No, right? Okay, so the final answer should be x equals to 1, y equals to 3. Okay, once again, me being Jiasu is back. You have your answer. How to check your answer in the exam? This is 3 marks. Sub this set of values into both equations and you must get 14 and 18 respectively. If you don't, means your answer is wrong. Okay, so take note of this. Okay, next part D, fraction equals to a fraction. What must you do when you see a fraction equals to a fraction? Give her the edges. Cross multiply, very good. So cross multiply, this times this equals to the other way around. So you will just get 5x minus 6 times 1. Okay, then from here you expand the whole thing and simplify. You will get 4x squared minus 13x plus 9 equals to 0, which according to the calculator can be factorized into 4x minus 9 and x minus 1 equals to 0. So x must be equals to 9 over 4 or x must be equals to 1. Finish. Okay, so expand one side equals to 0, you get a quadratic equation. Full solutions for this paper will be uploaded as well, so don't need to worry. I will only go through very quickly for portions that I think is quite simple and doable. Take note for this, once again, if you want to check your answer, you got a lot of time in the exam. Let's say you got a lot of time in the exam. You sub this value into your left-hand side, right-hand side, they must be the same. You sub this value into my left-hand side, right-hand side, they must also be the same. This is how you check your answers in the exam. Okay? But if you're struggling to finish your paper, then it's fine. I don't need to do this step. Okay? Okay? So a student online asked a very good question. Do we need to show the box method for your factorization portion? How do I go from this to this? Okay, the answer is it's good to have. But is it compulsory? No. At Sec 3, they don't really look out for this anymore. Okay, so even if you without this, you wouldn't be losing any marks. Okay, but if you want to put it down to be safe, go ahead. Okay, moving on to the difficult question. This is where it's time to get serious, right? Because this is a trivial question. Trivial question, before I start, let me just say once again. The first question that you must ask yourself is it a right angle triangle or a non-right angle triangle? If your answer is it's a right angle triangle, you use Tuakaso, or Pythagoras. If it's a non-right angle triangle, it will just be sine rule or cosine rule. These are the only two things. So you just need to ask yourself the first question, what kind of triangle is it? Then from there, you will never make the mistake of using the wrong method. So now we're looking for QR, which is in a right angle triangle. So what we'll use is Tuakaso. You have angle 25, opposite, adjacent, hypotenuse. So therefore, you are looking for O, you have A, it will be tangent 25. So tangent 25 is equals to QR over 2.2, which means QR will just be equals to 2.2 tangent 25 degrees. Simplify this 3SF final answer, you get 1.03. Okay, final answer 3SF. But if you want to ever use the length QR, use this one for working. Okay, that is for part A. Part B asked me to find the area of the plot of land. Okay, so wait, let me just copy the diagram. What's going on? Never mind. Don't know why I can't paste my screenshot, but okay, so let's say this is my area. We're gonna find an area of this plot of land. Same, you ask yourself, what kind of triangles are we working with, right? So from here, you have two different triangles, PSR and PRQ. So PSR is a non-right angle triangle, which means if you want to find the area of PSR, we must use your half AB sine C. So it will be half times 1.4 times 2.2 sine 42 degrees. Okay, this is for the first portion. Same thing, don't need to evaluate. You can leave this as it is first. Second portion for your triangle PRQ. Just now we found RQ already. So technically we can use my half times base times height. So half times 2.2 times my RQ, which is 2.2 tangent 25 degrees. So one is for PSR, one is for PRQ. You add both up together, that will give you my total area, which will be 2.16 km square, 3SM. Can. Like that, so you can write this plus this, you'll get the answer. It's fine. Okay. Then afterwards, when I move on to the last question, I think that's what everybody is worried about, like why you cannot solve this question. So let me move on to the last one. The question said, determine whether it is possible to build a circular fence such that the points PQ. No, it is not a Sec 4 topic. Okay, it's just trigo and properties of circle. Okay, so PQRS lie on the circumference of a circle. Justify the decision and show your calculations clearly. First thing first, in this question, did the question say where's the diameter? No. So can you assume? No. Because what students will always do is they say what? They say that PQ is my diameter. And since this is a right angle triangle, this is what we call right angle in semicircle, so it makes sense. But no, that's not how it works. Why? Because the question didn't say that PQ is a right angle. Right? So we cannot do this method. So we make use of another properties of circle that we learn. Okay, which is angles in opposite segment. Right? Angles in opposite segment is what we have learned in your properties of circle. So when we imagine this to be a circle, let's say this passes through this point like that. Okay, sorry, my drawing is a bit bad, but just take it as this is a circle lah, yeah. Okay. Let's say this is my circle, right? Your angles at circumference are what? SPQ and SRQ. These are my angles in opposite segment, right? Because SPQ covers this portion, SRQ covers this portion, and they make up one whole circle. This is the criteria for you to use angles in opposite segments. Okay, so from here we must go and find for me what is angle SPQ. So angle SPQ is just 42 plus 25, which will give me 67 degrees. Okay, then afterwards, what you need to go and find for me now, since I know what is this, you need to find for me what is SRP. So to find angle SRP, what you need to use is, what do you need to use? In this triangle, is this a right angle triangle? No, so what can I use? Sine rule or cosine rule, right? So if you are looking for SRP, so angle SR, sine angle SRP over the length opposite is 1.4. The only length that we know, or rather the only angle that we know is what? Sine 42. And what is the length opposite? SR, which we don't know. So you have to find for me what is SR, right? So to find for me what's SR, you must use cosine rule, which is why this is a 4-mark question. Because you have the length 1.4, 2.2, and the angle in between, you must find for me what's SR. So SR is equals to square root of 1.4 square plus 2.2 square minus 2 times 1.4, 2.2 cosine 42 degrees. And this will give me answer 1.49075. Now that you know SR, sub this back into my fraction. So you will get sine 42 over 1.4907. So from here, you are then able to calculate for me that sine angle SRP is equals to 1.4 times sine 42 over 1.4907, which means angle SRP must be angle P. .38 934 degrees, 3 decimal places. Okay, so once I get SRP, you are then able to find for me what is angle SRQ by taking 38.934 plus 90 degrees, which will give me 128.934 degrees. Okay, so from here, you have SRQ, you have SPQ. You're going to check for me what is the sum of SPQ plus SRQ, which will be 67 degrees plus 128.934. And this will give me a final answer of 195.934 degrees, which is 3 decimal place. And since this is not equal to 180 degrees, it does not exhibit what we call angles in opposite segments. And if they are truly an angle, they truly lie on the circumference of a circle, they will be able to satisfy angles in opposite segments. So since they don't, it just means that they don't lie on the circumference of the circle, therefore not possible. Not possible since angle SPQ and angle SRQ are not angles in opposite segments. Okay. Okay, all the solutions that online students you have missed out on, I will send into into the Telegram group. So let me just find the Zoom link, the link again. Okay, moving on to the next question. Before I move on, you got any questions? Confirm? Okay. Any questions? Okay. Question number 3. So properties of circle question, very common. You have things like angles in same segment, opposite segment, angle at center equals 2 times angle at circumference. How do you make use of this, or rather, how do you find all these angles quickly? Very simple. You look at the first and the last letter. For example, AOE starts with A, end with E. For you to either be in the same segment or opposite segment, just need to look for angles that start with A and end with E. So an example would be what? ADE, very good. And ADE lies on the circumference of the circle. AOE lies on the center of the circle. So what's the relationship between angle at center and angle at circumference? 2 times. So therefore, just 2 times 33 to give me 66, because angle at center equals to 2 angle at circumference. First thing. Okay, so that's part A. Second part asks me to find XAE. I'll just do it at a space at the top over here. So you have 66 degrees to be over here. XAE is over here. So the first thing that you must identify for me is that there is a right angle. Because over here, the question showed you that XY is a tangent. OA is known as my radius. So that means that angle OAX is equal to 90 degrees, because tangent, you can write this in your space for part B, but I'm writing here because I want to refer to the diagram. Okay, tangent perpendicular to radius. Then afterwards, if you want to answer what is the question, which is XAE, you must subtract away OAE. Then how am I going to find what's angle OAE? Very simple. Isosceles triangle. Why? Because OE is my radius, OA is also my radius. This is what, once again, I say students miss out on. So you get an isosceles triangle, angle OAE will simply be 180 minus 66 divided by 2 to give me 57 degrees. This is my base angles of isosceles triangle. Okay? No, because that's not an E-Math. Yeah. Okay, so E-Math, you cannot use an E-Math. So take note. Why did I multiply 33 by 2? Because this is my angle at my circumference, 33. This is my angle at center. So based on my property, angle at center equals to 2 times angle at circumference, you multiply by 2. 0. Okay, so therefore angle XAE will just be 90 degrees minus 57 degrees to give me 33 degrees. This one got no reasoning. Okay? Can? Okay. Okay. Then let me move on to the next question. Now you must explain why BA is parallel to CX. Okay, I will just write everything here because I don't want to keep referring to the diagram. So for BA to be parallel to CX, they want you to prove that these two angles here are parallel to each other. Okay, you have a few options that you can consider, right? Because the moment they are parallel means you have a three special angles that you can use: corresponding angles, interior angles, and alternate angles. So because they are parallel, that's why you can use this. So if you can prove to me that any of these angles are of this relationship, you are then able to answer the question. So to make your life easy, okay, over here we look at this angle 97. Okay, exam tip number 1, once again, the question usually will not give you an angle for fun. I use the word usually because sometimes they will just throw in there to confuse you. But we haven't used 97 yet. But in this case, if we want to use 97, we must use angles in opposite segments. Why? Because 97 is over here. The angle opposite of 97 must be this entire angle over here, which is BAD. Can you all see that? That their angles in opposite segment? Same thing, first and last letter. So B and D. So angle BAD will be 180 minus 97, which is 83, because of angles in opposite segment. Okay, then afterwards, if the entire angle is 83, this entire angle is 83, you realize that for you to use your alternate angles, you must form a Z, and the Z is over here. So right now, to you, BAD is 83 degrees. Angle ADX is 33 plus 50, which is also 83 degrees. So these two angles are now the same, and these are what we call alternate angles. And when can we use alternate angles? When there is a pair of parallel lines. So therefore, alternate angles, so BA must be parallel to CX. As long as you state for me alternate angles, you will get the mark. You don't need to write so long in English. Okay. Alternatively, you can use your interior angles by finding what is this particular angle over here. This plus this must give me 180 degrees. This is my interior angles. Okay. So to talk about this a bit more, to help you all remember this in the exam, right? I won't talk about alternate angles, right? Because it's just the Z. To differentiate between corresponding and interior angles, my concept here is very simple. Okay. These two angles here, they both face downwards. If they are facing the same direction, means they must be the same, which means this is what we call corresponding angles. If you have two other angles that are facing in opposite direction, they will be known as interior angles. So the blue color is interior angles. The green color is corresponding angles. Okay, this is the easiest way to remember which is which, because a lot of students struggle to remember or identify which is corresponding, which is interior. Look at the direction of the angle and you will get it. Okay? Any questions? If no questions, I'll move on to the graph questions. Okay, but for the graph questions, don't worry if you didn't plot. I'm not going to give you a workshop on how to draw a graph now. I'll only teach you how to answer your questions in the exam. Because you're not going to see this exact same graph again. Okay, sorry, there's one more question. Angle AXD. Now you must find for me what's angle AXD, which is this angle over here. I have already found out that this is 83 degrees. So now the question is, what is this particular angle over here? Right? I also know that this is 83 degrees. So therefore, to find angle DAX, it will just be, okay, let me write the top over here. Angle DAX will just be, 90 degrees minus away 83 minus 51. So what is 83 minus 51? You are finding this particular angle over here, which is OAD. And 90 degrees is OAX. So if you remove OAD from OAX, you will get DAX. So this will give you 58 degrees. Okay? So if DAX is 58 degrees, you have ADX will be 83. The last one, AXD, will just be 180 minus 83 minus 58 to give me 39 degrees. Angle sum of triangle. Okay, I hope you all got this question right. F, for those that tried, F. Okay, so I'll move on to your, what do you call it, your graph question. Okay, so when you look at this graph question, I mean, I have the answer for the plotting over here, but I won't talk about how to draw a graph. For part B, for this question, once you plot the graph, right, you want to find the gradient of the curve at x equals to 3. Even if the question didn't say draw a tangent, you must draw a tangent. And take note, when you draw this particular tangent, you only can touch the graph at one point where x is equals to 3. So if you look at the graph over here, okay, you will only touch at one point, which is x equals to 3 over. So in the exam, you must be very careful when you are using your ruler. So one tip that my teacher taught me last time was very simple. You know your ruler got transparent and opaque side, right? You use the opaque side and draw. You make sure you only see x equals to 3. You don't see anything else. Then from there, you will ensure that there's only one point, which is x minus 3. That is what you need to do. Okay? So that's for tangent. Once you draw, you must identify 2 points on the line, then find for me my gradient. Your answers are usually they have a range of 0.1, or if they're generous, 0.2, 0.3. So let's say the correct answer is 4.5, they will accept from 4.3 all the way to 4.7. So as long as you're within that range, you're good to go. So your graph, you cannot draw too ugly. And your tangent, you must make sure you only touch at one point. Okay? Second one, okay, you look at this x coordinate where the line intersects the curve. You just need to draw this line and find where the intercepts. That's it. So your line 7 minus half x. So when it's a straight line, your life is very simple because it's in a form of y equals to mx plus c. Whereby my gradient is negative half x plus 7, my y-intercept is 7. So from this equation straight away, you look at the graph, you have 1 point x-intercept. How to find the other point? You just let x be any value you want, sub in, find y, connect the two dots. Because for a straight line graph, you just need two dots to connect it. Not like a curve, you need a few points. So for a line, you find 2 points, you connect the dots, you get the answer. Okay? Afterwards, to find the x-coordinates, it's just the intersection point, draw a vertical line down to x-axis, and you'll get a solution. Okay, so I think this portion, your answer for your gradient, for those who did it, your gradient will be 0.721. So usually we'll accept from 0.7 to 0.74. If your answer is within the range, then congratulations. X coordinates, your answer will be between 0.55 to 0.65 or between 4.35 to 4.45. Okay, so for those who have done it, this is the range that we accept. Your answer is in between, you will get a correct answer. Second part, they ask you to find the equation in the form of this, which satisfy the values of x you found. The values you found is from the intersection between the line and the curve. So this is where you do your simultaneous equation, whereby you equate the line to be equals the curve. Then from here, you want to make your life easy, very simple. You see that it's a cubic equation, but you only have a quadratic equation. So you want to remove your denominator x. So you multiply throughout by x, you will get 7x minus half x squared equals to x cubed over 5 plus 4. So your x is gone, you have an x cubed, but you still have a fraction, right? So if you don't want the fraction, you can multiply throughout by 10. I think, yes, you can multiply throughout by 10 because 2 and 5, my LCM is 10. So multiply throughout by 10, and therefore you will get 70x minus 5x squared equals to 2x cubed plus 40. Make one side equals to 0, and you will get 2x cubed plus 5x squared minus 70x plus 40 equals to 0. Finish. So this is one way of asking you, whereby they give you a line and a curve, you equate them simultaneously and form one side equals to 0. This is not the difficult one. The difficult one is part D, whereby they want you to solve an equation using your graph, and they throw you a random equation like this. So whenever you see something like this, they phrase it in two ways. Either you can find it straight away, or they want you to draw a line. So the idea here is very simple. Whatever equation they give you, you must make one side to look like the curve, which is this. So you have to have one side looking like x squared over 5 plus 4 over x. In this case, you have x squared over 5 plus 4 over x minus 2 equals to 3. So you only want this portion. So you bring this over, and you will get x squared over 5 plus 4 over x equals to 5. But from the question in part A, when they introduced this curve to begin with, they told you that y is equal to x squared over 5 plus 4 over x. Which means instead of writing this, you can conclude that y is equal to 5. So you'll go and find where is the value y equals to 5. draw a horizontal line, find the intersection point, and that will be a solution. So this one's still quite easy, right? Because it's just a constant. In the event you get an equation such like this, let's say the question one, you solve this equation from the graph. You have to make one side to look like what you had. So same thing, this is what you had. So everything else, bring over, you will get x squared over 5 plus 4 over x equals to 2x minus 4. And then now you will be asked to draw this particular line over here. Y equals 2x minus 4, you must plot. Plot the line equate with the curve, intersection points will be your solution. Sorry?
They ever asked you to draw?
Rarely. I mean, I won't say no because I haven't seen every school in Singapore, but for now, I have never seen a question that will ask you to draw a curve on top of a curve. Hardest will be line. Okay, so take note, the concept here is you want one side to be the curve that you already have. Whatever is on the left is what you need to plot. Okay? And for my graph question, if you want to take a look at the graph, this is not drawn by a human being, this is from computer, so it's not going to be fair. But let me just put it in this perspective for you. Exam E-Math out of 100 marks for Sec 3. Graph question usually 10 marks. You scared you lose this 10 marks because your graph not nice, right? If everything else out of this 90, you get 90 out of 90. You need to worry about this? No, right? Can you control how well you draw? No, right? But can you control how well you do in the other questions? You can. So you go and focus on the other questions. Make sure you get above 85. The graph question, don't need to worry too much already. Understand this logic? That's what I did last time. Okay. Moving on to question number 5, you must show that the radius of this cylindrical container is 8.92. You only have the, what do you have? You have the volume of water in this cylinder. Okay, so for a cylinder, when you want to calculate your volume of water, it's always your base times your height. So volume is always my cross-section area times my height. Cross-section area means what? If you were to cut this cylinder into half, you will still see the same area, which is my circle. So in this case, my cross-section area for the water is this shape over here. And before you come and tell me that this is a semicircle, do we know that it's a semicircle? Do we know that this shaded area is a semicircle? No, right? So we cannot assume. So therefore, the safest way is what? To use my arc minus my triangle. So from here, you already have my angle to be 1.5 radian. So your shaded area, which is this portion over here, is my cross-section area. You multiply by 12, you will get your volume. So my volume is 240, which is equal to my area times my height of 12. So therefore, what you can conclude is that my base area is 20 cm squared. So my shaded area is 20 cm squared. How do I find my shaded area? Sector area, which is given by half r squared theta minus away my area triangle.
This one for base.
Base area. Oh, okay. Maybe it's a bit too confusing. So I'll just use CSA, okay, cross-section area. Okay. CSA, CSA stands for cross-section area. So from here, you must minus away the triangle using half AB sine C. So sine 1.5. And this must be equals to 20 cm squared. And then you must be wondering, how am I going to find r squared? Because you have so many unknowns, right? Very simple. Whatever that you're solving for, just like the same concept for algebraic, the formula. When you want to make D the subject, you factorize out D. You want to solve R, you factorize out R. So you will get 1 over 2 times 1.5 minus 1 over 2 sine 1.5 equals to 20. How do you know CSA is 20? Because volume is cross-section area times height. My CSA stands for cross-section area. So if my volume is 240, my height is 12, my cross-section area has to be 20. Because the question said that the volume of water is 240. Does it answer your question? Okay, I think so. Okay, very good. Okay, so afterwards, from here, another thing that you must realize is this is a number that you can key in the calculator, so it's fine. Don't need to panic. You will get r squared equals to 20 over 3 over 4 minus half sine 1.5. So you see, up to now, I don't want to evaluate, because if I were to evaluate, you must key calculator, you must write in 5 significant figures. Right? I don't want that. So what I want is I have my exact, then I just need to square root the entire thing. You square root this entire thing in the calculator. Make sure to change to radian mode because you're working in radian now. Your final answer will be 8.9220 5SF. Final answer 8.92. Yeah. Okay, so instead of writing 5SF over and over again, you just need to write it once and then you present in 3SF. Up to now, you all got any questions? No, because I realized this is the last question. No questions, right? Calculate the surface area of water that's exposed inside the container. Surface area that's exposed means you're not touching the container, which means it's only this particular rectangle over here. So you must find for me this area of rectangle, which is given by length times breadth. And I already know this is 12. So you want to find the area. Essentially, it is just line AB times 12. So you need to find for me what is AB. How to find AB in this case? What kind of triangle am I working with? Can somebody tell me what kind of triangle am I working with? Right angle or non-right angle? This triangle over here. This one. Is it right angle triangle? No, right? So non-right angle triangle, what can I use? Half AB sine C, sine rule or cosine rule. Right? Only these three things. But now the question wants me to find what's the length AB. Right? So to find length AB, you must use your cosine rule because you know my radius is 8.92. You know my angle in between is 1.5. You can find the length AB. Can? Okay. So therefore, to find AB, square root 8.9220 square plus 8.9220 square minus 2 of my AB, so 8.92 cosine 1.5. Same thing you must do in radian mode. Okay, so how do you check your answer whether you're doing radian mode or not, other than seeing the calculator, right? If you use in degree mode, trust me, your answer will be very, very weird. Or rather, it will differ a lot from your answer. So if you realize that your answer doesn't look very accurate, like my radius is 8.9, you calculate my AB and you tell me you have a 40 cm, or rather 100 cm. Then you realize that, okay, something is wrong. Then you go and check your calculator again. So this will give me an answer of 12.162. So 12.162. So afterwards, you want to find the area. It will just be 12.162 times 12. And this will give me a final answer of 146 cm square 3SF. So this is my area of rectangle, which is exposed. Meaning to say you are not touching the container. Is there a calculation error? 10.799. Okay, wait. No, are you in radian mode or degree mode? The exact same values over here? Cosine 1.5, not 1.3. Maybe 1.3 because my handwriting is a bit ugly. Right? Okay. Wait, sorry, but so far nobody asked me what's this word means. Y'all can read my handwriting, right? Okay. Is it 16? Oh no, it's 163. This should be 163. Which when you run off 3SF, you'll still get the same answer. Okay, so final answer is 2146. Just the in between this should be 163 instead of 162. Okay. Moving on to the next question. Now you have the container is modified by adding a hemisphere, right? Initially, you're adding a cone and a hemisphere. And now water is poured into the container up to the level, which is exactly at the halfway level, which means my volume of water inside is half. But now the question only wants you to find the area of container that is in contact with the water, which means this portion, and this portion. So your curved part of your cone is given by the formula pi RL. Your hemisphere is given to be half times 4 pi r squared. Then for cylinder, the curved surface area, how do you find it? That's what students always forget. So in the exam, you forget, when you roll your paper into a cylinder, ask yourself, my curved surface area is this portion over here. I open this up, what shape do I see? How to find area of rectangle? Base, length times breadth, right? This is my length, this is my breadth. You fold back into a cylinder, where was my breadth? The height. Where was my length? Over here. What is this over here called? Circumference of circle. So therefore, to find the curved portion, it will just be circumference of circle 2 pi r times my height. Or understand this portion? If not, in the exam you forget, just go and roll your exam paper up, it's fine. So first thing first, what I need to find for my cone is my slanted height. Just now I talked about slanted height already. It's not the same as my height. So I know my height is 10. My radius in the previous portion tells me that it's 8.9220. So therefore, L square will be equals to 8.9220 square plus 10 square. This is what we call our Pythagoras theorem. We are using Pythagoras theorem in this case. Okay? Because my radius is over here, my height is over here. So from here, L will be equals to 13.402 cm, 5 SI. Okay, that's for L. Then afterwards, the rest of the things we already know, because we know our radius is 8.9220. So you want to find the area of container that is contact with the water is exactly half, right? So if you know the total surface area, how do I find the answer? Divided by 2. So therefore, area will just be half of everything. So what's everything? My hemisphere. How to find hemisphere? Half times 4 pi r squared, whereby r is 8.9220 squared. Okay, that is for hemisphere. This is for hemisphere. Plus the curved surface area of my cylinder, which we all know is 2 pi r h. So 2 pi r h. This is for cylinder. Followed by my cone, which is given by pi rl. This is for my cone. Okay, a bit long, but this is the working. From here, you press the whole thing in calculator. Final answer will be 774 cm squared 3SF. Okay, the idea here is I don't want you to be too focused on the final answer, rather I want you to focus on the working, on how I derive all this working. So you got any questions regarding the working, please let me know.